Let's solve this implicit differentiation problem step by step. We need to show that when e to the y equals sine x, the third derivative of y with respect to x equals 2 times cotangent x times cosecant squared x. Let's start by taking the first derivative of both sides with respect to x. Using implicit differentiation, we get e to the y times dy dx equals cosine x. Now we can solve for dy dx. We get dy dx equals cosine x divided by e to the y. But remember, we know that e to the y equals sine x, so we can substitute this in to get dy dx equals cosine x over sine x, which simplifies to cotangent x. Let's take the second derivative. When we differentiate cotangent x, we get negative cosecant squared x times dy dx. Now, we can substitute our expression for dy dx. This gives us negative cosecant squared x times cotangent x. Finally, let's take the third derivative. Using the product rule, we get negative 2 times cosecant squared x times dy dx minus cotangent x times 2 cosecant x times dy dx. Let's substitute dy dx equals cotangent x again. This gives us negative 2 cosecant squared x times cotangent x minus 2 times cotangent squared x times cosecant x. Now for the final step, we need to combine these terms. Using trigonometric identities, this expression simplifies to 2 times cotangent x times cosecant squared x, which is exactly what we wanted to prove. And there we have it. We've shown through implicit differentiation that when e to the y equals sine x, the third derivative of y with respect to x equals 2 times cotangent x times cosecant squared x.